Hello, all the prestigious personalities and wonderful faces. Welcome back to my YouTube channel almost after a month. This is the part 2 of complex numbers, or you can say the basics of mathematics. Now, a complex number is a core concept of mathematics founded by Greek mathematicians in earlier times, maybe in 12th century, I guess. You can study the historical background of mathematics on any historical channel on YouTube, of course. But here we focus upon what is complex number and what is mathematics. Without wasting any further time, let's just start. It's me Aryan Kumar and we are just focusing upon subjectives on this channel. You can find physics, chemistry, mathematics and a plus point for you is free SAT course as well. We will just start with the flow with the playlists and here I am in front of you. So this is the part number two. We discussed what is mathematics in the part number one. That was introduction to me and mathematics basically. So if I again paraphrase my words, what is mathematics? That is like anything you see in the world is calculated by mathematics and it works on the principle of mathematics is actually mathematics. Now that might be kind of hard to you to understand, but if I say the study of structures, calculations, numbers, or size, shape is called mathematics. That can be of any shape, such as trigonometry, that is focused upon what? Triangle, of course. Geometry, focusing upon shapes, right? So that is how the math implies in our words. Even the screen or this camera you see in front of yourself is mathematics. The algorithms are working at the background. It is showcasing you that a person is speaking in front of you at a screen, but you don't know the mathematics behind it. Okay, if you see this, you might find that 22 per 09 per complex number, that is all machine learning. And again, in machine learning we imply the concept of core mathematics. That is all about mathematics. And let's just start with the complex numbers. What are complex numbers? If I give you an appropriate definition of it, it goes like a combination of any problem where we feel difficulty to solve and we apply radicands. Now, what are radicands? Let me just showcase you a blank screen at here, and you can definitely have an idea what are radicands. I can add any value here. I can add 2, maybe I can add 1 here, maybe I can add 4 here. That is how the radicands looks alike. Except then this, how we imply this in complex number. What are basically complex numbers? You can call it a formation of real and imaginary numbers alongside with a Greek letter that is called iota, or this Greek letter can be anything. This can be sine, that can be cos. Again, this can be 10. So these are basically our Greek methodologies that we use to calculate maybe a kind of geometry, mathematics, trigonometry, and a lot of various terms that we aren't even, you can say, used to it. Okay, so let me just write an equation for you and try to explain what is a complex number. If I type anything like plus, sorry, a plus b and I, okay, the small I basically. What does this thing means? And this is equals to z. So you might have guessed it that z is known as a complex number. If you have to denote z, so you can denote it as a complex number and you can simply do something like this, maybe. Yeah. So that is how we focus upon the complex numbers. Z equals to C. That is a sign, a icon for complex numbers. Now let me just uh, dive into the deep definition of it. Okay, so at this point, the Z was our symbol for, you can say, a complex numbers. At this point, A is our real part, B is our, you can say, imaginary part, and if I add iota to it, it also becomes an imaginary part. And what if I ask you what is an imaginary number right here? What is an imaginary number right here? Okay, you will simply say that is iota. How is that so? Because iota itself is called as a imaginary number. That's why we utilize it, we change the values, we amplify it, and iota is equals to a lot of various conditions. If I talk about iota square, that is significantly equal to -1, and if I talk about iota, that is equals to radical -1. So that is how we classify the definition of here. So the definition was combination of any problem where we feel difficult to solve, then we apply a radicand. So basically this is what a radicand looks like. Okay, that is what a complex number is in front of you. And I also configured somewhat a definition of mathematics as well. Now, what is a inverse, like what is the opposite side of a complex number? Like if there is a positive complex number, can there be any type of negative complex number? Yep, you are definitely right, there can be a complex number that is negative, but let me just clear my screen to just let you know how that thing works. Okay, so as we learned that if we apply the z equals to a plus b and then add iota in it, this becomes a complex equation. Meanwhile, if I change it into a negative, okay, negative equation, that will be like a minus b iota. That is quite simple, isn't it? But again, the main thing would be here that we would apply a conjugate here. So basically, if I turn the sign to its opposite side, that would apply a conjugate upon it. This sign is known as a conjugate, and therefore we consider it as a opposite side of any complex number. It can be a sign of multiplication that is being changed to somewhat a division, or a division that is being changed to a multiplication as well. That is how simple it is, isn't it? Yeah, so we covered complex number, a conjugate, how to form equations, and I have few homework tips for you as well. Uh, Not homework tips, homework questions for you. Equations basically. You have to solve iota power 3, iota, okay, these both are separate things. Iota power 4, iota power 5. And I'll give you a hint as well. Iota 2 is equal to -1. If you add it twice, what it would be, you can simply calculate it in your mind. You can do mental maths basically, and you can have your answer. This was all about our part 2 of basic mathematics, and I hope you like it. Thank you. That's it.